Welcome, everybody. In today's session, we're going to dissect the ins and outs of two different smart contract programming environments, Ethereum Solidity and Soroban's Rust. So without further ado, let's go ahead and kick it off. My name is Julian from the SDF, and I am a senior developer advocate role. I'm super happy to be giving you this tutorial today. So first things first, what is Solidity? So what is Solidity? Solidity is an object-oriented language tailor-made for writing smart contracts on the Ethereum blockchain, also known as the EVM. Its syntax is very similar to JavaScript, C++, and Python. So if you've had any experience in web development or backend development using JavaScript or TypeScript, Solidity will be very familiar to you. So what is the Soroban Rust SDK? It's a highly specialized set of tools designed for writing smart contracts on the Soroban smart contract platform. Unveiled in 2022, our core engineers are hard at work to bring you the best smart contract platform available. And best of all, it's built on Rust. So you can build things like DeFi applications, automated market makers, tokenized assets, and you can even leverage some of Stellar's core functionality, all from a smart contract environment. If you've had any experience in systems programming, WebAssembly, or Rust in general, a lot of what you see today in today's video will look very familiar to you. So in today's tutorial, we'll be developing two Hello World contracts side by side, first in Solidity, and then next using Soroban's Rust SDK. What we have here on the screen is your basic Hello World contract. So let's just go ahead and build this from scratch and step through the code. I'd say build from scratch, but AI kind of fills everything in. All we've done here is indicated the version of Solidity that the compiler will be using to compile the contract. So we'll go ahead and declare that contract. All right. We created our empty struct, and now we'll define a function here. Now that we've built the line for our function, you can see here that we're passing in one parameter, our string parameter 2, that is stored in memory. Now this keyword memory indicates that after this function is executed, it won't be stored in the smart contract at all, so you won't be able to reference it. This public keyword means that this function is callable from outside the contract. So if another contract were to get the contract address for Hello World, they would be able to call the hello function. This pure keyword indicates that this function is not going to need to view or modify or access or modify the state of the smart contract, and is exerting purely computational effort, mathematic logic, etc. And all we're doing is getting a string as the return data. So let's go ahead and define that string. All right, so let's go over this variable here. We have our string greeting that is actually a concatenation of the word hello and our two parameter that we're passing in the function. If you could see here, this cool global variable encode pack actually turns this data into its hexadecimal format. And what we're doing here with this string keyword is that we're just turning all of that data right back into a string, enabling us to get that string back the way we intended to. So let's go ahead here, deploy this to our local VM. We'll go ahead and pass world as our parameter, and we'll go ahead and call the function. So as you can see here, we have hello and 2, just as we have it here in our function. So now let's go ahead and break down what a smart contract looks like using the Soroban Rust SDK. So first things first, we're going to put a compiler indicator here that signifies that we're not going to use Rust standard library. This helps optimize the contract for smaller binary size, extremely important for blockchain development. Next, we're going to go ahead and do our imports. So this is going to give us the functionality and data types that we're going to need for the smart contract logic. One of the cool things about using Rust for smart contract development is that there's actually various SDKs out there that enable us to have this tailored functionality for the purpose of what we're developing. So now let's go ahead and define our empty struct contract. This declares a new public structure named contract that just serves as the base for our contract's implementation. Now this part, contract implementation, is an attribute macro applied to our contract's implementation, which actually tells Soroban that the code inside this implementation block, which we'll see later, is going to be the contract's main logic. This macro is super important because it exports the publicly accessible functions to the Soroban environment, making them invocable by other contracts or directly by transactions when they're deployed. So let's go ahead and get to the contract implementation itself. Let's go ahead and define our function here. So what we've just done here is written our hello function with the inside of the implementation block. It's a public function, meaning it can be called from outside the contract. It takes two parameters, env of type env and two of type symbol. Env is a type that encapsulates the environment in which the contract is running, and symbol is just a short string representation. This function returns a vector of symbols, which will actually just be returned as a string, similar to our Solidity smart contract. Now let's go ahead and break down the function itself. So the function itself actually constructs a vector with a reference to our contract's environment, a short symbol representing hello right here, represented as the string, and the symbol that was passed to the function to. The function's purpose is actually to create and return this vector as a string. So let's go ahead and compile that. We'll pass in hello, and our to will be world, and there we have it. Our return data returned as a symbol vector. All right, so that's the basic structure of a Hello World Soroban smart contract. Hopefully you learned something and have a better understanding of what it takes to write smart contracts with Rust. Now let's go ahead and do our compare and contrast between each contract. Let's go back to our Solidity side. So here we're actually declaring the contract here with the contract keyword and just defining it as Hello World, just as we did in the Soroban side. The only difference is we actually have to create a struct in Rust before we begin defining the contract itself. So both of these declarations just basically serve as the blueprint for our smart contract logic. So for functions, both Solidity and Soroban allow the declaration of a public function, which can be called from outside of the smart contract. The parameters we passed in and the return types differ based on the programming language. As you can see here, we're passing in a string and getting a string return. And as you can see here on the Soroban side, we're passing in a symbol and getting a symbol return, which is also just a string, just a different data type. So the use of the pure keyword in Solidity to indicate that the function doesn't modify or access the state of the contract is actually not needed when developing Soroban smart contracts. It's implicit in the Soroban Rust SDK due to the immutability of the variables in Rust by default. So both of these code snippets demonstrate how to manipulate and combine data. As you can see here, we're just combining this data into a straight vector or a vector of symbols, which is returned as a string. Here, we're combining the data through that global variable encode packed, which actually turns this data into a hexadecimal format and packs the end of that data with a bunch of zeros to kind of expand to the maximum size there. And then we're just transforming that back into a string. So the key takeaway from this comparison is that while Solidity and the Soroban Rust SDK share some similar concepts, their execution is distinct due to their differing design principles of their underlying languages. JavaScript is most similar to Solidity, and Soroban is built in Rust. So the benefits to building with Soroban is that Rust actually comes inherent with a couple of features, namely concurrency, safety, and low overhead for computational effort, which are all huge for smart contract development, and keeping in mind the bigger picture for node operators. Not having their nodes leverage, computational effort keeps transactional costs low and gas fees low, and overall it's just beneficial for the network. If you're looking for more resources on how to migrate from the EVM over to Soroban, we have this great documentational resource that I've written just explicitly for this. So we have the introduction here that's going to go over the basic principles of Soroban Soroban Rust compared to Solidity, all the way up to deploying your own smart contracts with Rust, and maybe even having an MVP of a vault afterward. So we'll leave the link in the description for you to check that out. Hope you learned something today, and take care.